Okay, let us look at a problem involving cars and motorcycles and the risks that are involved. All right. So John will be a high school senior next year. He wants to get a vehicle to celebrate his graduation. John's mother researched vehicle safety and found that 1 out of every 6 teenage drivers were involved in some kind of accident. While talking to his math teacher, John mentioned that he did not think the risk was high enough to be concerned. John decided to survey 800 students, 352 of whom were male, to help him convince his mother to allow him to get a vehicle. No student has both a car and a motorcycle. The following are the data from John's survey. Okay, we have the info here. Already it is given that the total number of students are 800. 800 students were surveyed and 352 of those are male students. So number of females, if I can get just by subtracting 352 from 800. That's one part done. Now we have a chart here which says males with vehicle. 221 male students are having cars and 42 male students are having motorcycles. Out of those 221 students, 62 students were involved in car accidents, and out of 42 motorcycle owners, 10 students were involved in accident. And number of females, you have 380 students are having cars. Out of those, 13 were involved in some kind of accident, and 13 girls were having motorbikes. 5 of them were involved in the accidents. This is the information we have with us now. So using this, we can come up with a Venn diagram and or a tree diagram to break down the given info and come up with a probability of knowing what are the risks that are involved in owning a car or a motorcycle. What is the percentage of probability, whatever it is, you can get all the information. Now let us draw a Venn diagram from the given information. I'll draw one rectangle first. Okay, then we will draw 3 circles. One, let us say that's representing the total number of males, and the second one is the number of people who are owning a vehicle, and the third is total number of accidents. Alright, the first, like I said, this is the male students. As we are dealing with John, who is a male student, so we are concentrating more on the information about the males. So the set males I'll put here. This whole circle is representing males, and here the total number of students who are owning vehicles. The second set is representing the number of vehicle owners, and the third set, like I said, the number of people involved in accidents. Right, these are the 3. Male students, car or motorcycle owners in the second set, and in the third, the number of accidents. Okay, let us make some more calculations here. Now, what is the total number of car and motorcycle owners? Add 221. This 221 is added to 42 to give me how much? 263. Right, 263 vehicle owners we have here. That is the total of owners, and total number of accidents that have taken place among these males is 62 plus 10, which is equal to 72. Right, let me mention total here. This is the total I have. And the third, total number of females who are owning whether a car or a motorcycle, that is 380 plus 13, that gives me 393. And lastly 13 plus 5 is equal to 18. Maybe these numbers will help us out. And already we have on the top here the total number of students, they are 800. So in this universal set I can write in the whole rectangular box represents it, or it is giving the information of all 800 students. 352 are males, you got it here. That is the total number of males. Now let us start from the innermost set, that is the most common region, that is how many students are the males, they own the vehicle, and they are involved in accidents. All the three conditions should be satisfied. So I'm looking for all those males who own either a car or a motorcycle and they are involved in an accident. So these are the males, they own car or a motorcycle and they are involved in an accident. So this number 72 goes in the innermost region. I'll write 72 here. That is 72. Now out of 352 males, it is given that 352 males we have. Out of those, 263 are owning a vehicle. 263. So on subtracting we get 89. This number 89 goes in the set of males who do not own a vehicle. Now also I have here this number 263. 263 are the male students who own either a car or a motorcycle. Out of them 72 are already gone. Take away 72. So 263 minus 72 gives me 191. Right, 191. That will be written here because these 191 students are the males and they are the vehicle owners. Of course, the total number of vehicle owners are 263. That 72 is separated because they were involved in accidents. So we are done with the male set. So if you add these numbers 89 plus 191 plus 72, you should end up getting this total number 352 males. That was the total you have. Now coming to this place here, we know that there are altogether this number 263 plus 393 owners of cars or motorcycles we have. Those 263 males, they own either a car or a motorcycle, and 393 female students own either a car or a motorcycle. So what is the total here? It is 656. So the total in the vehicles set, I should get 656. Now out of those 656, that number 18 females are involved in accidents. Now that number 18 should come over here because they are not males, so that they are females and they are involved in accidents. That 18 also is separated there. Now let us subtract these three numbers from 656. That gives me Okay, I'll type in 656 minus 191 minus 72, again 18, that is equal to 375. So I'll write here 375. So altogether this number 263 plus 393, those are the vehicle owners, either a car or motorcycle, and altogether males and females put together it is 656. So out of that 656, 191 are the males and they were not involved in accidents, and they have their car, of course, car or motorcycle. 72 are the males, vehicle owners, and they were involved in accidents. 18 students are the females and they were involved in accidents. And this 375 are the females and they were never involved in any accidents. That number 375 I can also verify by subtracting this 18 accidents number 18 from 393. 393 minus 18 gives me 375. Now just one more number is remaining. There are some females who do not own a vehicle. So where do you have to put them in this Venn diagram? This whole thing is for the males. That is the only vehicle owners. This is the accident set. So those young ladies' names should come outside these three sets. And what is that number going to be? You can get that number by subtracting the total of all these numbers from 800. Let us do that. We have here 89. Let me add plus 191 plus 72 plus 18, add 375. So that is 475. Now from 800, I'm sorry, it is 745. So from 800, take away 745. That gives you 55. So 55, that number 55 I can write outside those three sets. So those are the females who do not own a vehicle. And now the total, of course, it is going to be 800. And now you have all the information about the males, especially. Like we know how many students are there altogether. Out of that, what is the total number of males and what is the number of females, and out of those males, how many were involved in accidents, how many students are safe drivers. Basing on that, you can find the probability of a student who is involved in accident, right? Finding the number of students involved in accident, divide the total number of students who are owning vehicle. So likewise, whatever information you are seeking, that can be obtained by making use of this Venn diagram. Now we are also going to get all this information as a tree diagram. Let us look at it right now. Now let us break down the given information using a tree diagram. Alright, for that we have the total number of students, that's 800. Out of those 800, 352 are the males and 448 are females. So now what is the probability of males is P of M is equal to, I'll write P of M is equal to 352 over 800. That gives me how much? 352, let me turn it on, 352 divide 800, that is 0.44. 0.44. Now probability of females is equal to 448 over 800, and that must be equal to it is 448 divide 800, 0.56. 0.56. Here we can notice that 0.44 plus 0.56 is equal to 1. The total probability in any scenario, it must be equal to 1. Here you are finding the probability of males and females. So when you add them together, it must be equal to 1. That's what we have here. So first we have the probability of finding the males and females. Now let us look at the probability of finding the number of students who are owning cars, then motorcycles, and then those males who do not own neither a car nor motorcycle. Okay, so for that car I have to do total number of males, that is 352, and car owners are 221. So the probability P of males owning a car, that is 221 over 352. Alright, so 221 divide 352 is 0.6278. 0.6278. You can round it to the second decimal, that is 100th place, as 0.63. Alright, now students who are owning a motorcycle, males, probability of males having motorcycle, that is 42 over 352. 42 divided 352 is how much? I have here 42 divided 352 is equal to 0.1193. That 0.1193 I can, this 0.1193 I can write it as 0.12. Right, that is the probability of the students who are owning a motorcycle. Precisely, we are talking about males here, of course. Now the remaining out of 1, if you subtract these two numbers, we get the probability of the male students who do not own a car or a motorcycle. So let us go ahead and do that piece also quickly and see if the total is equal to 1. We have here how many students do not own a vehicle. from the previous slide, we have here these 89 males. They don't own either a car or a motorcycle. So I'll write 89 probability of none, no car or no motorcycle. That is 89 over 352. That will give us, let me write here, 89 divide 352, 0.2528, etc. So that rounding it, you'll get 0.25. 0.25. Right. Check these ones. Now probability of car owners 0.63. The probability of motorcycle owners 0.12. And probability of the students who don't own anything is 0.25. Adding all the three probabilities gives me 1.00, which is equal to 100. I mean 1 or 100% it is. So we are good with these numbers. In the same way, we can also calculate the probability for female students. How many females are owning a car? So the probability is 380 divide this 448. I mean 380 plus 13 is 393. That 393 I'll divide by 448. Then involved in accidents 18 over 448, and all those calculations I'll let you do, and I'll show you the tree diagram at the bottom. Now we have here males. From the total students, we have males here. I'll write males over there, males, and there females. All right, these are males. Okay, females, and the probability of finding the male here, male is 0.44, female 0.56. So let me write 0.44 and females are 0.56. Now out of males, we are looking for the car owners, motorcycle owners, and no vehicle owners, right? So let me write there, these are cars, okay, and there you have motorcycle, then you have none. All right, now what is the probability of finding the car owners? Males who own a car 0.63, motorcycles 0.12. All right, cars 0.63, 0.63, and 0.12 is the motorcycle, and 25 is nothing. So 0.12 motorcycles, remaining 0.25, they do not own anything. Now this is the second branch you got, the main branch, males, females, and that males branched out to cars, no vehicles, and motorcycles. And then from there, those car owners who were involved in accidents, no accidents. When you don't have a vehicle, you don't have to worry about involving in accident or not. So no branches are coming out of the none. But from this motorcycle, you have 2 branches coming out, and these are what? Accidents. There, no accident. There, motorcycle owners involving in accident, and there, no accident. Let me check it out. Yeah, that's right. Okay, and then let me write down those numbers. Car owners involving in accidents. These 62 out of 221, right? Let me divide that number. 62, turn it on, 62 divide 221. Total car owners are 221. 62 are involved in accidents. That gives me 28.2805. I can write it as 0.28. 0.28. Alright. 0.28 are involved in accidents. So the rest of them, 0.72, they are not involved in accidents. And in the same way for motorcycle, what are the numbers we have? Motorbike, 42 students are owning motorcycles. Out of 42, 10 of them are involved in accidents. So 10 out of 42, let me do. That is here 10 divide 42 is equal to 0.2380. On rounding it, I can get 0.24. Let me write 0.24. 0.24 are involved in accidents. So 0.76 are not involved in accidents. So now we have the whole picture about the male students. Out of the whole school, there are 0.44 males are there. Out of 0.44, 0.63, that is 63% are owning cars, 25% they don't own anything, and 12% they are owning motorcycles. And out of the car owners, 28% involved in accidents, and 0.72 or 72% are not involved in car accidents, etc. Now, if you want to find the probability of a male student involving in a car accident, what do? I'm looking for a probability of a male student in a car accident. Is equal to, the probability of finding a male is 0.44, 0.44. Finding a car owner is 0.63. So that times 0.63 times 0.28. 0.28. So this gives me the probability of a male here in owning a car and involving in an accident. So let us multiply these three numbers. All right, 0.44 times 0.63 times 0.28. That gives me 0. Okay, it is how much? 0.7. Right, 0.077616, etc. So on multiplying this by 100, or when I round it up, it will become 0.08, which is equal to 0.08, and 0.08, the percentage. When you write it as a percentage, it will be 0.08 times 100 gives you 8%. So the probability of a male student getting involved in a car accident is 8%. That's the one fact. In the same way, you can also find what is the probability of a male student who is involved in a motorcycle accident or not involving in an accident. Any information, whatever you want to know about the male students, that is available from this tree diagram, or you can also use that Venn diagram. That's how some problems are solved using probability. And now, after looking into all the information, you can decide whether it is good or bad, or risky or not risky, whether to own a car or a motorcycle, whatever it is. So you can come up with your own decisions. Thank you so much.